Greetings, M Squared here, and we are going to talk some more about polynomials. Today our goal is to simplify them. So when we simplify them, we need to combine like terms, but we need to make sure that we know how to find like terms and what that means. So like terms are the only ones that can be combined, and like terms have the same variable part, and that includes any exponents. So it's just like when you were little and you had like 3 apples on a page and 4 bananas, and they asked you how many apples, you just counted the apples. Well, some kids get confused with x's and x squared, so that's why I made this distinction. If I have a 3x squared or a 3x, those are not the same. The reason is that the 3x squared means I have 3x squareds. That means I have an x squared plus an x squared plus an x squared, and 3 of them I can write like this, 3x squared. Likewise, a 3x means I have 3 x's. So I have an x plus an x plus an x, which I can write as 3x. These are not the same. This number tells me how many x's I have. This number tells me how many x squareds I have. X squareds and x's are not the same. So I cannot combine those. So you have to be really careful with that. 3x plus 3x squared equals 3x plus 3x squared. So when we look to combine like terms to simplify polynomials, we want to make sure that we only look at the like terms. So when I start looking at this polynomial and realize that I have some things I can combine, one of the things I do is I might take a highlighter or a pencil and I might circle all the things that say x squareds. So the number in front tells me how many I have. So over here I have a negative 4x squared, and over here I have a negative 1x squared. Remember, if there's no number in front of it, it's kind of like a 1. So if I have negative 4 and I subtract 1, I actually have negative 5x squareds. So I might take my same highlighter and just underline the next like terms. Those are x's. This one says I have 8x. This one says I'm subtracting 6x. So if I have 8 x's and I take away 6 x's, I am left with 2 x's. And finally, my constants. 7 plus 2 is 9. So I have simplified my polynomial. It is negative 5x squared plus 2x plus 9. Okay, on to the next one. So I see some y squareds, I see this y squared, I see this y squared, and that is all the y squareds I see. So I'm going to take 18y squared, I'm going to use the sign in front of the term, plus 2y squared, and that would get me a 20y squared. Now for the y's I see I have a negative 1y there, a 4y there, and a negative 3y there. So if I combine those, negative 1y plus 4y gets me 3y. 3y minus 3y gets me 0 y's. And if there's 0 y's, I don't really need to write it down. There's 0 y's. 0 times y is 0. So the y's canceled out. And now I'm going to look last at these guys. 16 minus 10 is 6. So my simplified version of that is 20y squared plus 6. Sometimes you'll see that they put the polynomials in parentheses to distinguish this is a binomial plus a binomial versus just a bunch of monomials added together. But I do the same thing with respect to the like terms. This one is like this one, and it says plus in the middle. So every time I cross this, I'm going to be adding. So it says 3x plus negative 6x. Well, 3x plus a negative 6x is negative 3x. And negative 4 plus 7 is 3. So my simplified version of that is negative 3x plus 3. And then over here I have 7x squared minus 3x plus 15. That's a trinomial, a quadratic trinomial. I'm adding in to another quadratic trinomial. So I'm going to again get out. Actually, I'm going to do this one different. Let me show you how to do this vertically. So you remember when you were little and you had like 119 plus 23 and you lined them up and you said 9 plus 3 is 12, and you carried the 1 because you can't put 12 in the one spot, so you have to put the 10 over there. So you have 2 plus 20 plus 10 plus 10, that's 40, right? And there's our ones place, so that was a 4 representing 40s because there were 4 10s. And then you have a 1 representing 100. So there's 100, 4 10s, and 2 1s, so we have 142. Well, you can do that same thing with like terms. you can say, okay, I'm going to add these two together. So I'm going to line them up. I'm going to write the x squareds under the x squareds, the x's under the x's, and the 15 under the numbers, and then I can add vertically. Another way to do it. So negative 20 plus 15 is negative 5. 14x minus 3x is 11x. And 2x plus 7x squared is 9x squared. Notice I put a plus sign right here. Normally if I said what's 14x minus 3x, you'd say 11x. We wouldn't put a plus sign, but because we're writing it in standard form, and because there's a term in front of it, we want to write the positive down, the plus sign. We don't need to do it here because there's no term in front of it, but remember we need to separate them by plus and minus signs because that's what a trinomial is. They're separated, monomials separated by plus or minus signs, or the sum and difference. Okay, so now we have a little rectangle, and it says find the perimeter. So hopefully you remember how to find the perimeter. Perimeter means you're adding up all the sides. So what do you remember about a rectangle? Because if we have to add up all the sides and they don't give us two sides, hopefully you remember what you're supposed to remember about a rectangle, and that is that opposite sides are congruent. So that means I know this side automatically to be the same as its opposite side, and same thing over here. This one's going to be x squared plus 7x. So now when I add them, what I do is I just say, oh, okay, here's all my like terms. So 3x squared plus x squared is 4x squared. And if you think about it, those two are going to be the same, 3x squared plus 4x. So 4x squared plus 4x squared is 8x squared. So those are my x's. X squareds, I should say. And you can't see that because I zoomed in too much. Zoom out. Away. Okay, so then I say, well, what's 7x plus 2x? That's 9x, and this is going to get me a 9x too, and 9x plus 9x is 18x. And then lastly, I have two constants, so 10 plus 10 is 20. So the perimeter is 8x squared plus 18x plus 20. A lot of people don't like that that's the perimeter because they want it to say like 15 inches or 42 meters, but we're looking at polynomials, so we are going to express the perimeter with a polynomial. So if we ever found out what x was, we could figure out exactly how many inches or meters or feet it is. But for right now, that is what we have. Now, it's a little bit different when you subtract. So I'm going to show you some subtraction ones. And this can sometimes get a little confusing. So we're going to do this on a different day, but I'm just going to make the video the same class. So here we go. When we subtract, remember, 5 minus 3 is the same thing as 5 plus a negative 3. That's 2, that's 2. So subtracting is the same thing as adding the opposite. So subtracting is the same thing as adding the opposite. So a lot of people will say, oh, it's subtraction. That's the same thing as adding the opposite. And then they'll take the opposite of each thing in the parentheses. That is one way to do it. The other way to do it, I'm going to show you over here, is to use your distributive property, 2x plus 14. And remember that there's like a negative 1 out there. Remember, on our distributive, we distribute that number, and if you want to think of it as like a negative 1, there's a minus sign. So we get 2x plus 14 minus 20 plus negative times a negative, 8x. So either way, we get the same thing, but it just depends on how you want to think about it, adding the opposite or using your distributive property. And then we go back, since it's the same as adding, we go back to what we did before. There's our like terms. What? 2x plus 8x is 10x. 14 minus 20 is negative 6. And now I'm going to show you how to do it vertically, kind of like what we did just a minute ago. So we're going to say, remember, it's really important that you put this one first when you're subtracting, because that subtraction doesn't have the commutative property, meaning that 5 minus 3 is not equal to 3 minus 5. Those are different things. So we want to make sure we do it correctly, putting the first one on the top if we're doing it vertically, and the next one here. So before I add them, remember, I'm going to distribute that. So it's a minus a negative 5x squared. That's a 5x squared. It's a minus a 4x, so it becomes a negative 4x, and it's a minus a negative 12, which becomes a positive 12. Some people, let me get a different pen, some people just leave it like this and they just change this. So they do the adding the opposite. They change this sign and then they make all the opposites like that. There's different ways to do it. Let me zoom in so you can kind of see that a little bit better. That pen is kind of a hard color to see. Okay, so either way, we're doing a 5x, a minus 4x, a 5x squared, sorry, and then a positive 12. So now that I change that, now I'm just adding, because subtracting is the same thing as adding the opposite. So 11 plus 12 is 23. Put a plus sign there because those are both positive. Negative 9 minus 4 would be a negative 13x. And 2x squared plus 5x squared is 7x squared. So that is my polynomial after I subtracted those two. So let me show you. I'm not going to do this vertically. I'm just going to do it like this. So I change these, right? And then I'm just going to say 2x squared plus a negative 2x squared. Well, 2x squared plus a negative 2x squared, those would cancel. So I have no x squareds. So on to my x's. 4x plus 5x is 9x. And negative 6 plus 6 cancels out. That's a 0. Negative 6 plus 6. So my answer is 9x. And sometimes things cancel out, and that's okay. You could even get a 0 maybe if everything canceled out. Alrighty, make sure you watch your signs there on subtraction. It gets a little tricky if you forget that. So good luck with your adding and subtracting and simplifying polynomials. M squared signing out.